Hi, welcome back to Leetcode. So in this video, I am going to discuss the third problem from today's weekly contest 513, that is count of unfinished task after each shift. So what is the problem statement? Problem is that you are given two integer arrays, task and shifts. Task I represent the time required to complete the ith task. Okay. Shift j represent the amount of time available during the jth shift. So there are two different arrays. So what will happen that the size may be different. Okay. The task must be processed in the order from left to right. Okay. So one is situation possible that carry over. If a task is not completed during a shift, processing continues from the same point in that task during the next shift. So that means suppose for one process to process, I need actually suppose 10 hours. But in the current shift, whatever the time actually I have left, that is actually suppose 6 hours. So I will actually work 6 hours on the same work, same task, and I'll complete whatever actually I can do within this 6 hours. Okay. And for the next 4 hours, what actually I will do for the next shift? First I will process this task that actually I have left in the last shift. Okay. So this is actually situation carry over. That means not able to complete the task in the current shift. So I'll process what actually the remaining task that will complete, or I will process in the next shift and restart. When actually I will call this situation restart. So when actually if all the tasks are completed during a shift, the shift ends immediately. Okay. Any unused time in that shift is discarded and the next shift begins again from task 0. Okay. So a task is unfinished if it is not fully completed. This includes a task that is currently in progress. So we have to return an array answer, where answer j represents the number of unfinished tasks immediately after the jth shift. That means when actually calling this jth shift, so after completing the jth shift, I have to see that how many still or actually a task I have still to do, still to process. Okay. So let's see the example 1. So first of all, this is the task order. From they mention that I have to process from left to right, and this is the shift. 3 shifts actually I actually have. So for the first shift, answer of 0 shift, how actually calculate? So total hours actually time actually I have, that actually 9 hours suppose. And for to process the left to right, so first task I have assigned, that is the first, this is the task. So how much time it will take? 1. Can I process this within this time 9? Yes, because 1 less than equal to 9. Okay. Next, try to complete the second task. Can I actually complete this within this time 9 hours? 1 plus 4, yes, less than equal to 9, because this is 5. Next, the third task can actually complete within these 9 hours. Let's see how much time it will take total. It will take 9 hours. Okay. And also I actually have 9 hours. So this is 9 less than equal to 9. So I can complete all of these 3 tasks. So that's why how many tasks I have to process? 0. After this shift 0. Got it? Now for the shift after the fix, I have to see that if I do the shift 1, so after completing the shift 1, how much tasks actually I actually have, how many tasks actually I actually have to process. So they mention that in the last shift I have processed all the tasks. So again, so what do I have to do? Restart. So restart situation is, what is the restart situation? Again I'll start from 0. So to process the first task, how much time it will take? 1. 1 less than equal to 1. Yes. So I can do that. So next is, can I do the second task? So how much time it will take? 5. Is it less than equal to 1? No. So I'll stop here. So before going to the next shift, is there any task actually I have that actually I have completed partially, that I'll do, that I have to do the remaining task I have to complete on the next shift? No, because it will take 1 hour. It is completed 1 hour. Got it? So that's why no carry forward, carry over. Got it? And what will be our answer after this shift 1? So I actually have still 2 tasks to solve. So that's why answer 1, it will be 2. Got it? Next, I go to the next shift. that is the second shift. That means I have to calculate what is the answer of the shift 2. After shift 2, what will be our answer? So how much time actually I have? That is 4. Okay. And task I have to complete, that is I have already processed this task. So first task actually I have to do, that is 4. So 4 less than equal to 5, 4, yes. This task will take 4 hours, and actually I have 4 hours. So that's why I can complete this. Try to fix the next task. 4 plus 4, it is 8. 8 is less than equal to 4. No, I cannot complete the next task. So after the second 0, 1, 2, yes. After the second task, how many actually remaining tasks I actually have? Total I actually have 3 tasks, and I process till this second task. Yes. So remaining task it will actually 1. Got it? So that's why our output will be 0 to 1. Got it? Let's compare with our expected output. Yes, 0 to 1. Got it? Let's see this example 2. So example 2, first shift, answer of 0 I have to calculate. So time actually I have, that is actually 20. Okay, 20. Now first task it will take 2 hours. 2 less than equal to 20. I can solve this. Next, try to take the second task. So how much total time actually I need? That is 5 hours. Is it less than equal to 20? Yes. Next, continue, try to solve the next task. It will take total time 2 plus 3 plus 4, it is 9. 9 less than equal to 20. Yes. So answer 0. It will I have completed all the tasks. So that's a remaining task actually I have, that still I have to do process, that is 0. So that's why it will again start for the next shift. Again I'll start from the beginning. So in the current shift, how much time shall I actually have? 4 hours. Okay. Again I'll start from this index 0. So how much time it will take? 2. First task it will take 2 hours. 2 less than equal to 4. Yes. So I can complete this. So try to go to the next task. How much total time it will take? 2 plus 3, it is 5. 5 less than equal to 4. No. This is less than equal to 4. No. So I cannot process this task. So that's mean I have to stop. So I have completed this task completely. And within this task, for the second task, partially how much time actually I have invested there? That is 2 plus 2 hours. So total time is actually 4. And for the first task, I have completed 2 hours. So remaining 2 hours I have invested in the second task. Got it? So ultimately you can actually imagine that I actually have previously it was 3, 4, and after this I have already invested 2 hours on this task. So remaining actually I need 1 hour only. Got it? So modified array will look like something 1, 4. Got it? So for answer 1, how much tasks I have completed? Only 1 task I have completed completely. And how many actually tasks still I have to process? That is 2 tasks actually I have still to process. So that's our answer 1. It will be 2. Got it? Now the equivalent array will look like something like this: 1, 4. Why not 3, 4? Because for this task I have already invested 2 hours. So that's why I need only 1 hour more. Got it? And this is I have not invested any time on this task. So that's why it will still 4. Got it? Now for the next task, how much time shall I have? That is 5. That is 5. So I'll complete this task. Yes, 1 less than equal to 5. I can complete. I'll complete this task. Try to do the next task. Try to complete the next task. That is, it will take 4 hours. So 1 plus 4, 5. It is less than equal to 5. Yes, true. That means I'll complete this task also. Got it? And now after this shift, I have completed all the tasks. So that's why our answer of 2, it will be 0. Got it? So I hope the example and how it's trying to calculate the expected output, it is clear, right? Now how actually can solve this? So 2 situations are possible. How actually 2 situations are possible? One is that our shift time, it is enough to solve all the tasks. Got it? This is the case 1. And case 2, it is actually that our time, how much time actually I actually have in the current shift, that is not able to process all the shift. Right? So there may be one situation of carry over. That means we can actually process some tasks partially. Correct? That situation may arise for this case too, because either what will happen, either this situation is possible that I will complete this task completely. Suppose one will be completed because the shift time it is also 1 hour. So that's why this task will be completed fully. And still, so there is no such situation of partial process, right? So that's why I'll go to the next shift. When it will go to the next shift, so I'll again start from completely from this task. Again start from, it will take time 4 hours, not any reduced time. Got it? So that's why there is a maybe a chance of carry over. We have to see that. So how actually we can check that? So ultimately, if there is any carry over, okay. Suppose if I first of all see what is the prefix sum. So for this task 2, 3, 4, 2, 3, 4. This is actually the time it will take to process each task. Got it? So if I actually store the prefix sum, what actually it will store? It will store 2. Now it is still 5 and it is 9. So what actually indicates? So this is the prefix sum. So it indicates that if I start from 0 to 0, it will take 2 hours. If I actually solve 0 to 1, it will take 5 hours. So if I solve 0 to 2, it will take 9 hours. Right? This is clear. Now, what actually I have to do? I know this is the prefix sum. Okay. And if there is one situation that our time, how much time shall I have in the current shift, that is already greater than or equal to 9. This is greater than or equal to 9. That means I will processed all the task, right? So that time our answer will be 0. Correct? I can do that easily. I can calculate that. That if our current type shift time is greater than or equal to the total prefix time of prefix sum of all the tasks, that means our answer will be 0. There will be no remaining, no unprocessed or task. Got it? So this is for the case 1. Now I have to handle the case 2. So how to handle the case 2? So suppose actually I have some shift time. Suppose it is for this example 2, our shift time it is suppose 20. It will arise on the first case, but for the second task, second shift, that is time is 4. Okay, shift time is 4. So that means I want to know that how much after this shift, how many actually tasks will still be there to process. Correct? So I actually have 4 hours, but within 4 hours, how many tasks actually I can complete? If I again start from this index, so it will be 2. I can complete this. 5. It will take 5 hours, but actually I have only 4 hours. That means I can complete till this. Correct? Complete this task till this task. So how many still actually I have? How many tasks actually still actually I have to process? Total actually I have n. N minus this index. This is 1. Right? That means 3 minus 1, 2. Got it? How actually calculating the still actually I have how actually calculating the how many actually tasks are there still to process. Got it? So n is, I know that how many total actually length actually 3, and this index I want to know that how much actually I can how many tasks I can complete. This index still 1, index 1. That means index 1 means I can solve or I can process till task 1. So that's why our remaining how many tasks you will actually have 3 minus 1. Got it? That's why it will be 2. Clear? So that means I have to do only the upper bound. Upper bound of start or shift time. Right. Now one thing which I haven't handled, what the next situation, that I can solve the first task in the second shift, right? Because I actually have 4 hours. I have completed this task, so that's why our answer will be 2. N minus 3 minus 1. I have completed one task. But for the next step, what actually I have to calculate? I have to carry over this, right? This carry over. That means I have already invested 2 hours. Whatever the remaining time I actually have in the last shift. So 2 hours it will be actually shifted, or it will be carry over to the next shift. So that means for the next shift, how much time shall I actually have? 5 hours. 5 hours. Okay. And in the last shift, how much time shall I actually I have invested? That is total 4 hours. Total 4 hours actually I have invested in the last shift. 2 hours for this task and 2 hours for the next task. Correct? So total in the till this current shift, how much time actually I have total invested? That is 9 hours. Correct? 9 hours. It is clear. I have invested till this current shift. I have invested 9 hours. So with it, by using the 9 hours, how many tasks actually I have completed? I can complete. This will be completed. This will take 2 hours. If I try to solve this 0 to 5, 0 to this index 1, it will take 5 hours. This will also be completed. So from 0 to this index 2, it will take 9 hours. So it is still less than equal to 9. So I can actually fix all of this task. So how many total tasks actually still there to process? 3 minus 3, it is 0. Got it? So that's why, got it? How easily I calculate, trying to calculate the how many still tasks are there still to process. So that means how actually I can solving this problem, that somehow I have to calculate, I have to store that the carryover from the previous shift, how much time I have invested for in the till the last shift and in the current shift, suppose T. So that means first of all how much time I have invested after this shift, after this current shift. So that will be carryover plus the current shift. Got it? This much time actually I have invested till now. So this is suppose total T. So now this upper bound I have to find out that how many tasks I have completed. Got it? So that will be ultimately n minus x. Suppose this is the x tasks I can complete. So total n tasks actually is there. So our answer will be n minus x. Got it? Now when this carryover will be reset to 0, because time it will be this current shift time, correct? But carryover it will be actually like carryover will, I have to go to the for the next shift. I also have to modify. I have to store the value. But when it will be reset to 0. So when I have completed all the tasks, right? That time what will happen, that when I am going to the next shift, that time I do not have any tasks that I have completed till now. So that time it will again start from 0, kind of scratch. Like when is trying to solve the first shift. Got it? So again it will try to only add the current time of the current shift. Got it? So let's explain this flow with this example 2. So this, suppose first shift, it will be initialized to 0 because this is the first shift I am trying to do, and this is a task start from 0, and this is the prefix sum 259. Okay, 259. Now this is 20. So past shift, I have not invested any amount of time in the past, so that's why it is 0. So 0 plus 20, so it is 20. So total time actually I have invested after this shift, that is 20 hours only. Got it? So by using the 20 hours, how many kilowatts I can solve? I have solved all the tasks. Correct? Because this is maximum time, it will take 9 hours, and actually I have 20 hours. So that's why our answer of 0, it will be 0, and our this will be reset to, again reset to 0. Past shift, because I am going to again start from this 0, this task. Right? That's why I have, that means I have not invested any time, right, any time in the past. So again I'll start from, go to the next shift, that is 4. Okay, so how much time, how many tasks actually I can complete? That is only one task, right? So our answer 1, it will be 3 minus 1, it is 2. Got it? And before going to the next shift, how much time shall I have invested till now? That will be modified with 4. Why 4? Because 4 hours actually I have invested in the current shift, 4 hours. Got it? So that's why in the past shift I have invested 4 hours, because it may actually carry some incomplete task, right? So that's why I'll go to the next shift now. So time is 5. Okay, and from the past shift, how much time shall I have invested? That will be past shift plus 5, that is 4 plus 5, it is 9. Okay, it is 9 hours I have invested till now. So how many actually tasks I can complete? That actually these three, all of these three actually will be I can complete. So remaining task, it will be 3 minus 3, it is 0. Got it? Why our answer is 0, 2, 0? This is clear. So if you still any doubt, you can just follow this flow again, that how we are trying to calculate and how we are trying to reset this past shift. So it will be reset only if we have processed all the tasks, because there will be no any chance, there will be no chance to carry some time from the past. And why I'm trying to carry all total times, not the actually the partial time what is still processed. So because we have the prefix sum, so if I calculate the total time actually invested, suppose t, and it can process this many times. Ultimately we want to know that how many tasks they are still there to process, unprocessed. Correct? So that's why it actually not matter, it doesn't matter that like we are trying to calculate the how many partial process or something processed in the past, in the last shift or not, something like that. We want to know that how many actually still they are left. So that's why I had to know that only the total time. So if I actually calculate how many times I can, how many tasks I can solve with partial, without partial, plus with the current time, current shift time. So that's why it is trying to store the only the total time, not the partial time. It is trying to propagate from the last shift. Got it? You can follow that. Now go to the code. So n is the total task. How many tasks are there to process? Now I have to calculate the prefix sum. So that's why here actually you can just simply check that for prefix 0 there is no possible of prefix sum with the left index. So that's why it will assign as a task 0. And for I is equal to 1 to I less than n, it will actually see what are the prefix I. It will store the prefix sum of till I minus 1, and what are the time for the current task. It will add that. Now for the current time means this is how much time actually I invested in the past. Got it? So initially it is 0, because this is the first time I am trying to calculate. So it is 0. So from the past shift, how much time actually I have invested in the past, that is 0. Initially it is 0. And vector of integer that I have to return, that after this current shift, how many actually tasks are still there to process. Okay. And now actually I am trying to shift, trying to process from left to right? And first this shift will suppose come 20. Time is 20 hours. Okay. And current time from the previous from the past, this is 0 plus current shift. That means the current time total, how much time actually invested till now, that will be current time done. That will be whatever from the past plus the current shift time. What? So if it is greater than equals to the prefix sum of all the, like at the end, the prefix sum of all the task, that means I can complete all the tasks. So there is no tasks are there to process. So that's why our answer will be store 0. In the answer vector I will store 0, and I will reset this to 0. Why it is reset to 0? Because if I do not want to reset this, so what will actually happen? It will actually mean that for the next shift, that still actually have some work. I have done some work, may have done some work in the past, but actually not. I am starting from the first again from I am starting from scratch, means the first task. So that's why it will be reset to 0. It should be logically right. So that's why it will actually handle the that situation, that when I'm trying to process some partially and trying to carry that for the next shift, but it will handle that. Actually, for the else case, you can see that for the else case, first I will see that how many work I can complete, how many tasks. Okay, so it depends on the upper bound of the current time, how much time I have invested. So it will give me the those many work actually I have done, correct, completed work, and I'll store n minus how many actually tasks actually I have completed, n minus total tasks I have completed. Here actually you can see that before going to the next shift, I am not resetting this current time done to 0. Why? Because this is not the first time I am again I'm starting from scratch. It is sub intermediate shift, so it may have some tasks that I have processed partially in the current shift that I have to continue for the next shift also. So that's why I will not reset this. And I have already mentioned that how actually handling this current shift, current time done in the case of suppose this case when I'm trying to reset and again start from here. So 20, it will reset again, complete all the tasks, and then it will again reset to 0, index 0, task 0. Now if I add this 0 plus 4, that means I have invested till now 4 hours only. Got it? So I will check the how many work I can complete. I can complete the first task only. Got it? And then I will go to the next shift 5. So how much total time I have invested till now? 4 plus 5. Why I am not counting 20? Because 20 already I have consumed for all the tasks to complete, and also it is reset it. Got it? So again I will go to the next shift. Got it? And ultimately return the answer vector. I hope this is clear. And what is the time actually for this? So this is a one for loop. It will actually take big of n, and this is also big of how many actually shift are there. So big of n, and there is no okay, there is some upper bound. So this is kind of to find a number in the sorted vector, kind of sorted array. So it will take log n. So ultimately it will time velocity, it will be n log n. Got it? So it will work for the length of 10 to the 5. Got it? And I have shared this code in the description. You can check that. If any doubt, any suggestion, you will comment on that. If you like this video, please like the video. If you are not yet subscribed, please subscribe channel. Thank you. See you in the next video. Bye bye.